Hi friends, in this video we are going to discuss two more problem about functional dependence and independence. So here question, so these two examples are very important. So here, so check whether the given functions u comma v are functionally dependent or independent. If they are functionally dependent, then find the relation between these two function u comma v. So here, how to solve is the following. First I want to solve example number 1. So here so first I will solve example number 2. So here after that I will remove this. So here answer of my example 2. So here given u equal to x plus y by 1 minus xy and v equal to tan inverse x plus tan inverse y. Now I want to check u and v are functionally dependent or independent. If dependent, find the relation between u and v. So here, therefore, j equal to Jacobian of u comma v with respect to x comma y, which is equal to, so here partial derivative of u with respect to x, partial derivative of u with respect to y, partial derivative of v with respect to x, and v with respect to y. Therefore, now here if u is this, so here I want to find u x. So here again the quotient of two functions, so denominator as it is. Here derivative of numerator with respect to x is 1 minus x plus as numerator as it is, derivative of denominator with respect to x. So here derivative of 1 minus xy with respect to x is, this is simply minus y whole divided by 1 minus xy whole square, which is equal to, so here which is equal to, so here which is equal to, just write here numerator. So here 1 minus xy, here just multiply minus into minus plus x y, and this is minus minus, so here plus y square divided by, this is 1 minus xy whole square. So here xy gets cancelled, this is equal to 1 plus y square by 1 minus xy whole square. Now this is my ux. I want to find uy. So here uy equal to partial derivative of u with respect to y. So here 1 minus xy as it is, partial derivative of numerator with respect to y. So here 1 minus x plus y as it is, partial derivative of denominator, that is 1 minus xy with respect to y. So here this is minus x whole divided by, so here 1 minus xy whole square, which is equal to, so here 1 minus xy, so here minus x plus, so here this is plus x square, so here minus minus plus, and this is plus xy whole divided by 1 minus xy whole square. So here this is minus xy plus xy gets cancelled, which is equal to 1 plus x square by 1 minus xy whole square. This is my u, so this is my uy. Now I want to find vx and vy. So here vx, partial derivative of my this function v with respect to x. So here tan inverse x is 1 by 1 plus x square and tan inverse y. So here partial derivative of this function with respect to y. So here 0 plus, here 1 by 1 plus y square. So here now I want to write here therefore Jacobian equal to u comma v with respect to x comma y, which is equal to determinant. So here ux, value of ux is 1 plus y square by 1 minus xy whole square. Uy, here 1 plus x square by 1 minus xy whole square, and vx is 1 by 1 plus x square, and vy is 1 by 1 plus y square, which is equal to, so here determinant, here 1 plus y square divided by, here 1 minus xy whole square into 1 by 1 plus y square minus, so here in minus 1 plus x square divided by 1 minus xy whole square into, so here this is 1 by 1 plus x square. So here this cancel with this, so this cancel with this, which is equal to 1 by 1 minus xy whole square minus 1 by 1 minus xy whole square, which is equal to 0. Therefore here Jacobian is 0, therefore u comma v are functionally dependent. Therefore here, therefore u comma v are functionally dependent, are functionally dependent. Now I want to find the relation between u comma v. So here how to find is the following. Now just observe one thing. So here given u equal to x plus y by 1 minus xy and v equal to tan inverse x plus tan inverse y. So tan inverse y. So I want to find the relation between u comma v. So here let here tan inverse x equal to, let's say, a, and tan inverse y equal to, let's say, b. So here this implies, so here x equal to tan a and y equal to, this is tan b. Therefore u equal to, so here u equal to x plus y. So here tan a plus tan b, so here x plus y divided by 1 minus tan a into tan b. So here tan a tan b, so here which is equal to, so here tan a tan b, so we know tan of a plus b equal to tan a tan b divided by 1 minus tan a tan b. So here which is equal to u equal to tan of here a plus b. So here this is the formula of tan a plus tan b equal to tan a plus tan b divided by 1 minus tan a tan b, which is equal to tan of, now tell me if this is here, so just observe one thing, so tan inverse x plus tan inverse y, so v equal to tan inverse x plus tan inverse y. So here a plus b, so here a plus b, so here a is this and b is this, so this implies tan inverse so this is my a is tan inverse x plus b is my tan inverse y. So here which is equal to tan, so here the value of tan inverse x plus tan inverse y is v, therefore u equal to tan v is the relation between two functions u comma v. So here this is my relation between u comma v, therefore u comma v are functionally dependent and the relation between u comma v is u equal to tan v. So this is my relation. Now I want to solve example number so 1. This is my example 2. So in the same way I will solve. Please pause and write this. So this example is very important. Now here example 2 says, so here I remove my example 2. Now I want to just solve example 1. So here u equal to sin inverse x plus sin inverse y and v equal to x under root 1 minus y square plus y under root 1 minus x square. Check u comma v. So discuss the check functions u comma v are functionally dependent or independent. If dependent, find the relation between u and v. So here this is example. Now directly I will solve. Therefore Jacobian equal to Jacobian of u comma v with respect to x comma y equal to, so here determinant ux, this is uy, vx and this is vy. Therefore I want to find ux. So here derivative of sin inverse, so partial derivative of this function with respect to x. So derivative of sin inverse x is 1 by under root 1 minus x square and derivative of u with respect to y is 1 by under root 1 minus y square. Now I want to find partial derivative of v with respect to x. So here v with respect to x. So here this is my simple constant. So derivative of v with respect to x is simple under root 1 minus y square plus y by y times. So here derivative of 1 under root 1 minus x square is here 2 and 1 by 2 1 minus x square. Here derivative of root x is 1 by 2 root x into derivative of, so this function 1 minus x square, derivative of 1 minus x square is minus 2x. Here just 2 gets cancelled, this 2 gets cancelled, which is equal to here under root 1 minus y square. So this is minus, so here minus xy by under root 1 minus x square. So this is partial derivative of v with respect to x. In the same way, I want to find partial derivative of v with respect to y. So here I want to find partial derivative with respect to y. So here x by here 2 root 1 minus y square into this is 2y plus, so here so this is simple 1 minus x square. Derivative of y with respect to y is 1. So therefore 2 gets cancelled. So which is equal to minus xy by under root 1 minus y square plus under root 1 minus x square. So this is my vy. Therefore Jacobian of u comma v with respect to here x comma y, which is equal to determinant. So here ux is this 1 by under root here 1 minus x square, uy is this 1 by under root 1 minus y square. Sorry, here I need some more space. This is ux. So here I want to write directly over there. So here Jacobian I will write here. So therefore Jacobian equal to Jacobian of u comma v with respect to x comma y, which is equal to determinant. So here ux 1 by under root 1 minus x square and uy 1 by under root 1 minus y square. Here this is ux uy. So vx is, here is vx under root, so here 1 minus y square minus xy by under root 1 minus x square. Now vy, this is minus xy by under root 1 minus y square plus under root 1 minus x square. So this is my determinant. Now which is equal to, so here product of these two things. So here 1 by under root 1 minus x square, this into this. So here minus x by y under root 1 minus y square plus under root 1 minus x square minus, so here this into this 1 by under root 1 minus y square into this is under root 1 minus y square minus xy by under root 1 minus x square. So which is equal to, here I want to multiply this throughout bracket, minus xy divided by under root 1 minus x square under root 1 minus y square. Now plus under root 1 minus x square by 1 minus x square minus, here multiply this under root 1 minus y square by under root 1 minus y square, minus minus gets plus, this is xy by under root 1 minus y square into under root 1 minus x square. Just observe one thing. So here this is positive quantity, this is negative quantity, this is positive quantity, cancel. Here this is positive quantity and this is negative quantity, cancel. This is equal to 0. Therefore the Jacobian is 0. Therefore here u comma v are functionally dependent. Here if u comma v are functionally dependent, now we have to find the relation between u comma v. How to find is the following. So here u is given, u equal to sine, here sine inverse x plus sine inverse y, and v equal to, so here x under root 1 minus x square plus y under root 1 minus y square. Sorry, under root 1 minus y square. So here u equal to, so v equal to x under root 1 minus y square plus y under root 1 minus x square. This is the given. Now here u equal to sin inverse x plus sin inverse y. So here let sin inverse x equal to a and sin inverse y equal to, let's say, b. So here this implies that x equal to sin a and y equal to sin b. So here sin inverse x equal to a, sin inverse y equal to b. This implies x equal to sin a, y equal to sin b. So here this implies x square equal to sin, let's say, sin square a, and if x square equal to sin square a, therefore x square and here, and let's say y square equal to sin inverse, sorry, sin square b. Now here I want to write, this implies that x square equal to 1 minus cos square a. Here 1 minus sin square theta plus cos square theta equal to 1. Sin square theta can be written as 1 minus cos square a, and I want to write y square equal to 1 minus sin, sorry, 1 minus, so here cos square b. This implies that, so here I will write cos square a as 1 minus x square and cos square b as 1 minus y square. So this implies cos a as under root 1 minus x square and cos b is as under root 1 minus y square. Therefore, just observe one thing. So here v x equal to sin a, here x equal to sin a under root 1 minus y square equal to cos b. Therefore v equal to, here x, the value of x is, this is my sin a, under root 1 minus y square is my cos b, plus here y is my sin b, so y is my sin b, and under root 1 minus x square is my here cos a, so this is my cos a. So now just sin a cos b plus cos a sin b. So here b equal to sin of a plus b. So here a is my sin inverse x and b is my sin inverse y, which is equal to, here I want to write here, therefore v equal to sin of, here a is my sin inverse x, so sin inverse x plus b is my sin inverse y, sin inverse y, which is equal to sin of sin inverse x plus sin inverse y. This is my u, therefore v equal to sin u, therefore v equal to sin u, or we can say u equal to sin inverse v. So this is the relation, either this or this. This is the relation between u comma v, as a u comma v are functionally dependent. If these are dependent, so this is my relation between u comma v as a function. So here these two examples are very important. So here just go step by step. So this is the important part. If they are dependent, how to find the relation between u and v. So here this is the way to find the relation between u and v in sine function. So in last example we have discussed how to find the relation between tan. So maybe they will ask sine, cos, tan. So just follow these formulas. Just once go through the trigonometric identities so that you can get one idea. So with this we finish this two problem. So thank you.